Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's papers. A simple enlargement followed by a rotation where students scaled from the wrong point and left no intermediate coordinates. Result, 0 method marks. Sound familiar? If you've ever finished an answer and felt sure it looked right, but the marks didn't add up, you need to hear this. Section 1. What an enlargement does on coordinates. Promise, we'll cover the centre, the scale factor, including fractions, and the exact steps to calculate new points so the examiner can award method marks. First, draw a quick diagram. Pick a centre of enlargement, call it C with coordinates xc, yc. Choose two non-collinear points on the shape, for example A at 2, 1 and B at 5, 3. Write those coordinates down. Don't skip that. Write it down. Don't just think it.
Now, the rule in words, to enlarge a point P from centre C by scale factor K, you take the vector from C to P, multiply that vector by K, and add it back to C. In coordinates, that's P dash equals C plus K times P minus C. If P is xy and C is xc,yc, then P dash equals xc plus K times x minus xc, yc plus K times y minus yc. Say K equals 2, doubling distances from C. If K equals a half, every distance from C halves. That's why fractional Ks are just as natural. They shrink instead of stretch.
Can you show that with our example points? I find numbers help me picture it. Absolutely. Centre C at 1, 0. Point A at 2, 1. Vector CA is 1, 1. If K equals 3, multiply that vector by 3 to get 3, 3, then add to C, A prime equals 1 plus 3, 0 plus 3 equals 4, 3. For point B at 5, 3, vector CB is 4, 3. Multiply by 3 gives 12, 9, and add to C gives B prime equals 13, 9. Write both intermediate coordinates. A prime equals 4, 3, B prime equals 13, 9. That written intermediate step is where the M marks live. The examiner wants to see you used the centre and scaled correctly. Marks are there for the taking.
Section 2. Rotations after enlargement and why order matters. If the question now asks for a rotation of 90 degrees anticlockwise about the same centre C, you must rotate the enlarged points A' and B', not the original A and B. The general rotation rule for a point xy about centre xc,yc by 90 degrees anticlockwise is translate so C is origin, rotate via x minus xc, y minus yc to minus y minus yc, x minus xc, then translate back. In short, P double prime equals xc minus y minus yc, yc plus x minus xc.
Do it together. A-C equals 3, 3. Rotate 90 anticlockwise to minus 3, 3. Translate back, add C gives A double dash equals minus 3 plus 1, 3 plus 0 equals minus 2, 3. For B dash C equals 12, 9, rotates to minus 9, 12. Adding C gives B double dash equals minus 8, 12. Say that out loud as you write it. A double dash equals minus 2, 3. B double dash equals minus 8, 12. Read the question twice, solve it once. Let that sink in.
Very important note. If you swap the order, rotate first, then enlarge, you will almost always get different coordinates. Enlargements change distances. Rotations preserve angle but not scale, so the operations do not commute. If the exam says first enlarge, then rotate, you must show the intermediate enlarged coordinates. If it says rotate, then enlarge, show the rotated coordinates first. The examiner wants to see your order written clearly.
Section 3. exam technique and the quick win combined. How are the marks awarded? Typical layout. M1 for identifying and using the centre of enlargement, M1 for correct scaling of at least 1 point, M1 for calculating a second point correctly, and A1 for the final accurate coordinates. For the rotation part, you'll see M1 for the correct rotation formula or vector step, and A1 for accurate final points. If you write nothing but the final answers with no intermediate steps, you risk losing all M marks and only getting A marks if the answers happen to be correct.
What are the common presentation errors that actually lose marks?
3 things. 1. Not stating the centre of enlargement explicitly. Write centre equals xc, yc. 2. Mixing up the vector direction. Always use p minus c, not c minus p. 3. Not showing intermediate coordinates after the enlargement. The examiner can't award method marks if they can't see you did the scaling. So our presentation checklist is short. Name the centre, show vector arithmetic, write intermediate points, then show rotation steps. Write it down, don't just think it.
Quick win. The 2-point tracking method and a 10-second back check. Choose 2 non-collinear points A and B. For each, write original coordinates, vector from centre, scaled vector, intermediate point after enlargement, and final point after rotation. That's your 2-point proof that the whole shape has moved correctly. Then do a 10-second back check. Measure the distance from C to A and from C to A prime. The ratio should be K. If K was 3, distance CA prime divided by CA must equal 3. This catches most scaling errors in seconds. Don't skip the check. Don't skip the check. That feels doable in an exam. Could you give a really short practice question to try now? On graph paper, C equals 0, 0. Triangle with vertices A, 1, 2 and B, 3, 1. First enlarge by K equals a half centre C, then rotate 90 degrees clockwise about C. Show your intermediate coordinates for A' and B', then the final A" and B'. Time yourself for 6 minutes and follow the 2-point tracking checklist. You can find worked solutions and more questions at jcacademyonline.co.uk.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Visit the site to download the practice worksheet that matches this episode. Stay curious.
Until next time, trust the process and nail that exam. Stay curious.